You probably have one in your pocket right now. You fold it, crumple it, and hand it across a counter without a second thought. From the front stage, a banknote is just a piece of paper, entirely ordinary. But backstage, the creation of that paper is an intense logistical operation built around a massive operational contradiction. The facility must mass-produce millions of identical physical objects every single day, while treating every microscopic scrap of material as if it is a priceless artifact. The process begins at the secure loading docks. Banknotes aren't made of standard wood pulp paper. Instead, they are a specialized blend of cotton and linen designed to survive for years rather than weeks. When these pallets arrive, they enter a closed-loop logistical chain, where every sheet is weighed with scientific precision. Because this raw material could be used to print perfect counterfeits if it left the building, the facility cannot operate like a standard factory. It is designed as an invisible web of spatial design and automated paranoia. Simply counting finished sheets at the end of the day is a security failure. Counting is prone to human error, and it only tells you what survived the process, not what might have been pocketed or lost during it. To eliminate that risk, automated guided vehicles handle the movement of all material. These robots navigate the factory floor along designated invisible magnetic or laser-guided grids, carrying stacks of blank sheets between isolated security zones. This diagram shows how the system acts as a physical audit. If an automated vehicle drops off exactly 2,000 pounds of blank paper at a printing station, the resulting printed sheets, plus any damaged scraps, plus any dust swept from the floor, must equal that exact same mass when they leave that station. If the numbers do not match down to the gram, the system assumes a breach. Doors lock. The automated vehicles stop moving. The production line halts. A missing gram of paper could mean a piece of substrate was slipped into a shoe or dropped down a drain. The facility's architecture ensures that matter is neither created nor destroyed, only physically transformed and strictly accounted for. The ledger of mass is the ultimate anti-theft system. Once the blank material is verified, it has to be turned into currency. But if the facility used standard commercial printing methods, anyone with enough capital could buy those same machines and replicate the product in secret. This is a metal intaglio plate. The designs for the currency are engraved into these thick, heavy plates, and the ink is flooded into these microscopic grooves. It is a mechanical process so specialized it is nearly impossible to replicate without industrial-grade equipment. The ink itself, especially the color shifting and magnetic variants, is a highly secure asset. To prevent tampering, it is stored in centralized vats and pumped through a network of hidden steel pipes directly into the sealed presses. No human hand ever touches the raw ink. To get the ink out of those grooves and onto the cotton paper, the press uses immense force. It applies dozens of tons of pressure per square inch, the physical weight of a commercial airliner pressing down on a single sheet of paper. This pressure does more than just lay ink on the surface. When you run your fingernail over the portrait on a bell, that distinct raised texture is the cotton paper itself, which has been permanently crushed and molded by the metal plate. It is a physical anti-counterfeiting measure achieved through sheer industrial violence. But applying ink that thickly creates a massive bottleneck. Because the ink is pressed so deeply into the paper, it does not dry instantly. If you were to stack these sheets immediately, the weight of the pile would cause the wet ink to ruin the entire batch. The facility must dedicate a huge percentage of its physical footprint purely to letting money sit still. Freshly printed sheets are stacked in protective cages and moved into curing vaults where temperature and humidity are aggressively controlled to ensure the ink sets without warping the paper. As the sheets emerge, they pass through an automated optical inspection pipeline. High-speed sensors capture images of every note in milliseconds, cross-referencing them against a perfect digital master. If a flaw is detected, like a smear the size of a pinhead, the system physically diverts the sheet off the primary belt. The sheets that pass inspection move to the final mechanical challenge, the cut. Currency is printed in massive sheets of up to 50 notes, and they must be sliced into individual bills with zero margin for error. Cutting a stack of 100 sheets at once is difficult because air trapped between the layers can cause the middle sheets to slide. To prevent this, massive hydraulic clamps squeeze every microscopic pocket of air out, turning the stack into a single solid block of cotton before the industrial guillotine blades come down. This precision is a core requirement for financial stability. If a cut is off by a fraction of a millimeter, the asymmetrical borders make the bill look like a counterfeit, causing automated ATMs and vending machines to reject it. What happens to the defective sheets rejected by the scanners? They cannot simply be thrown in the trash. Even if a sheet has a smudge, it remains a highly restricted currency substrate that would be valuable on the black market. The facility operates a secondary closed-loop network dedicated to destruction. Defective notes and scrap edges are routed into the destruction wing, where industrial shredders pulverize the fibers into a fine confetti, making it mathematically impossible to reassemble. Even this dust must be accounted for to balance the ledger. The pulverized waste is fed into hydraulic compactors that crush the confetti into dense, solid bricks. These are weighed and verified against the original loading dock intake numbers. Only when the waste has been structurally destroyed and the mass has been verified is it finally allowed to leave the building as trash. The finished, perfect currency is stored in massive, automated vaults. These are often operated by robotic cranes, ensuring no human needs to walk the aisles until the money is ready for transport. When an armored truck finally leaves the loading bay, it represents the culmination of an intensely paranoid supply chain and a triumph of physical control. The next time you pay for a coffee, consider the infrastructure required to put that bill in your hand. It is an everyday object that only exists because it survived a relentless gauntlet of laser-guided robots, extreme industrial crushers, and atmospheric control.